Hello everyone, my name is Rahul Rajput and my qualification is BTech UIT Kanpur. So we will be start the solution of a questions. This questions is belongs to the wave motions. The question says that in the given figure, this is the figure, the string has mass 4.5 gram. Means the string has mass. This is the massful string, not a massless string. This is the massful string. So mass of a string which will be equals to 4.5 gram. 4.5 gram. Find the time taken. Find the time taken by transverse pulse produced by transverse pulse. Okay, that produced at the floor to reach the pulse. Reach the floor to reach the pulley. Sorry, to reach the pulley, not the pulse. To reach the pulley. Okay. Means we have to time from if we produce the pulse, transverse pulse. Do you know about transverse wave? Transverse wave, let us suppose I string is given. If we produce the just one pulse from any one end, okay, and other end will be the fixed end. So if we produce the pulse, then the wave motion is this situation. So this is the transverse wave. Longitudinal wave is what? If longitudinal wave is what? If we take a hammer, and we are taking a part of a iron. This is the, let us suppose this is the solid cylinder. If we hit the any one end of by the hammer, then that is the particle is oscillating about the longitudinal wave. Means in this iron, the waves will be the longitudinal wave, and in string the wave will be the transverse wave. Implies that we can say here this is the string. So string, we have produced the pulse at that point flow. You know, suppose this point is A and that is the pulley up to pulley. Means if we produce the pulse at A point, then that is the goes at B point. So pulse is going for that situations. So this is the transverse pulse. Okay. We have to need the time taken from A to B. Means we have to need the time taken from A to B. Time taken from A to B. The time equal to, we know that the time equal to the distance upon velocity. Understand? Distance by velocity. Distance means A, this point is A, this point is B, because we have to record the time taken from A to B. Okay, so distance is taken from A to B. So d of A to B, and velocity on that string. Means we have to need the velocity for the transverse wave, not a velocity of the particle. Okay, for transverse wave, let us suppose this is the transverse wave. Okay, the transverse wave is this situation and particle wave is this situations. This is the particle just up to velocity. This is the velocity of a transverse. Okay, transverse wave is this situation. So this is the transverse wave. W means velocity of just up the velocity of the wave, or Wt means velocity of a particle. Okay. So we produce a transverse wave. This is from A to B. So time taken from A to B equal to distance upon velocity. Distance means this is the from A to B and divided by velocity. Velocity means we have to need the velocity of the wave. Velocity of the wave. Okay. This is the interesting point. Velocity of the transverse wave. We know that V equal to root of a T by mu. T is the tension, or mu is the mass per unit length. This is the important point. T is the tension and mu equal to mass per unit length. T is the tension in string. Tension in string. T is the tension in string. Mu is the mass per unit length. This is the mass per unit length. Mass per unit length. Okay. Means speed of a wave for transverse equals to root of a T by mu. Let us suppose this the string is given. So we have to need the speed of a wave in string equals to root of a t by mu. Always remember that. T is the tension on that string and mu is the mass per unit length. Okay. This is the mass per unit length. So mass will be distributed uniformly. Mass per unit length is what? Look here. Mass per unit length. Mu equal to m by L. M means total length upon total mass upon total length. But this is the for uniform. Let us suppose this is the string. This is the string. Uniform means the mass will be distributed on same cross section area. Okay, mass will distributed same cross section area. So this is the uniform. Let us suppose mass is distributed for that situations. So mass of the length, total mass divided by total length. Total length. This is the total mass divided by total length. Okay. So that will the uniform mass will be distributed here. Then we can apply the mu. Mu equal to for total mass upon total length. Okay. But for that situations, the strings goes from that point to that point. Means let us suppose this is the C point. This is the C point. Okay. So what is the total string? Length of total string? A to B or plus B to C. Also this is the counting here. Okay. So you can say A to B and B to C. Total mass here. This is not a confusing point. Let us suppose this point goes from that point. Okay. So AB plus BC is the total length. AB plus BC is the total length of the string. Okay. And total mass is given. Means this is the given point. Mass of the string equal to 4.5 gram. Okay. So this is total length. Total length means this is the total length. LT equals to the AB plus BC. Not a confusing point. AB plus BC. This is a B. Let us suppose this point. Okay. So this is AB plus BC. Okay. No problem. So you can say AB. AB is what? 2 meter. AB is what? 2 meter. Plus BC. BC equal to 2.5 centimeter. This is the 2.5 centimeter. 2.5 centimeter equal to 2 meter. You can convert the centimeter into meter. Imply that you can say multiplying the number 10 raised to minus 2, then that centimeter converted into the meter. Imply that you can say 2 plus 2.5 into 10 raised to minus 2. This is the total meter. Total meter. Okay. This is the total meter. 1 minute. This is the confusing point. 2.5 centimeter is correct or incorrect? I am looking that. Yes, 2.5. Sorry, this is the 25 centimeter. Okay, that is the okay. No problem. 25 centimeter. Sorry for that. This is the 25 centimeter. So 25 centimeter, 25 into 10 raised to minus 2. So minus 2 is goes at that situations. Minus 2 equal to 2.25 meter. Okay. So this is the total length. Total length upon total mass upon total length. Total mass is what? This is the equal to gram. So gram you can convert it into the kg. Equal to 10 raised to minus 3 kg. Total mass of the string. So mu equals to the. So mu equals to the mass of the total mass of the string upon total length of the string. So you can say total mass of the string 4.5 into 10 raised to minus 3 divided by total length 2.25 meter. Okay. So also you can calculate here that point equal to minus 3. This is the point. So that point is goes here. Point will be cancelled out here. Okay. 10 raised to minus 3. So 10 raised to minus 1 into 10 raised to minus 2. 10 raised to minus 1 is goes from 0 point equal to the 45 divided by 2 to 5 into that number equal to the 100. Okay. Into equal to the number 100. So that 5 9 ja 45 divided by 5 2 ja, or you can say if we taking the root 5 2 जा 1 मिनट, 5 9 जा 45, देन 5 5 5 को 20, 5 को 20 और 5 25, ठीक है, 5 को 20 1 मिनट है, 5 को 20 इंटू 5 25, 5 विल बी कैंसिल हियर, 5 9 45 और इंटू 100 इक्वल टू 9 डिवाइडेड बाय दैट नंबर, ओके, सो 9 पन्ना 45 5, so this will be number equal to the 1 divided by 9 पन्ना 45 500, okay, this is the mu point is there, okay. So mu equal to the 1 divided by 500 kg per meter, okay, because mu equal to root of that number, sorry, mu equal to that आपका mt divided by lt, this is the mu, and also we have to need the value of a v. V means v equal to root of a t by mu, t by mu equal to root of a t. T is what? T the tension, important point. T the tension in the steam. So tension will be same, means in that point if we taking ABD of that point, the tension will be away the system. If we taking ABD of a pulley, then tension is the away the system, If we taking the ABD of 2 kg, then tension will be away the system. So this is the tension T. But we are exactly draw the ABD of a 2 kg. So there are the two forces will be applied. First tension and second weight. Weight means vertically downward. So weight, if mass is given m, then weight mg is vertically downward. So this is the weight mg. Weight mg means 2 into g, and this is the tension T. So tension T and 2G, tension T upward and 2G will be downward. But this whole up 2 kg will be at rest. So T minus 2G equal to 2 into 0 means balance force T equal to 2G. Okay. So tension T equal to the 2G. T equal to 2G. 2G means G equal to 10 is the given point. So this is the 20 Newton is the tension. Now we can put the value of a T and mu. The value of a T will be equal to 20 Newton and mu equal to 1 upon 500. Okay, 1 upon 500. So we can simplify here, that 500 goes to the 200 equal to the, this is the 500 into the 20 equal to root of, this will be 5 to the 10 into, that is the 1 2 3 30, net 0 equal to the 40 equal to the 10 raised to 2 meter per second. Okay, so velocity of for the string, velocity of transfer wave in string, which will be equal to 10 square meter per second. 10 square means you can say 100 meter per second. Okay. But we have to need a time taken from A to B. Okay. So this is the important point. Time taken from A to B is what? If we discuss time taken from A to B. So time taken from A to B, distance is taken A to B. Distance A to B equal to the 2 meter. Okay. So that is the 2 meter divided by V. V means speed of transverse wave. Transverse wave means this is the 100. So that point equal to the 100. Okay, meter per second. So time taken from A to B, which will be equal to that number. So you can simplify your 0.02 meter per second. This is the time from A to B.